10-6 worksheet. So step 1, they want to simplify 5 factorial right here. Remember, factorial just means multiply by every number below it until you get to 1. So you get that. So 20 times 6 is about 120. 7 factorial over 6 factorial. So remember, the shortcut here is you could rewrite 7 factorial as 7 times 6 times 5 times 4 times 3 times 2 times 1. Or, for short, 7 times 6 factorial. And then the 6 factorial cancels, and you just get 7. It's an ugly 7. There you go. Next one, you want to use the same idea. So what we're going to do is expand the top one till we get to the biggest one on the bottom, which is 6. So that's going to be 8 times 7 factorial. We're going to leave the 6 alone. And then for 2 factorial, you expand the smaller one here, you expand it out. So 2 times 1. And I messed up. On top should go 7. I should go one more. Let's see. Where's my eraser? 8 times 7 times 6 factorial. See, now they cancel out. I was like, wait, they didn't cancel out before. So now they cancel out, and you just get 8 times 7 over 2. I hate 8 times 7, so I'm going to reduce it first. And I get 4, and I get 28. 6 choose 4. So this is a combination. It's the same idea as this guy, just written a different way. So there's the formula for this, which is NCR, which is the same way as saying this, which is another way of the formula is n factorial over n minus r factorial times r factorial. Or simply put, the top one on top, the bottom one on the bottom, and then subtract them. 6 minus 4 is 2. So that's how we do these. You go, if you want to do it the same way as this way, you go 6 factorial, 4 factorial, and then subtract them, 2 factorial. So again, we're going to do the exact same thing. We're going to rewrite 6 to 6 times 5 times 4 factorial. Right, up until you get to the highest one on the bottom. And then you can rewrite 2 as 2 times 1. Let's reduce things. 4 and 4. I get 6 times 5 over 2. These reduce. And you get 15. Next one, so now we know the idea. We can just do this one. 7 factorial is 7. That's the same as 7 factorial over 4 factorial. Subtract them, 3 factorial. If I want to expand this, do the top one until you get to the highest bottom one. Over 4 factorial, we expand the smaller of the two bottom ones. 3 times 2 times 1. These reduce. 3 times 2 is 6. That cancels 6. Oops, sorry. And then 7 times 5 is 35. 9 factorial, sorry. 9 over 9, 9 choose 9, is the same as just 1. I think I talked about this in the video, but there's a couple key ones you should just memorize. Anytime the same number is over itself, it's just 1. Anytime it's something over 0, it's just 1. And then if it's over 1, it's just the top number. And if the difference is 1, so that was a little funky, that's the top number also. So if I had like 9 over 8, that'll just be 9. So we'll see a lot more of that when we start doing these. So now I want you to find n and p of each of these. So here, the key thing knows that the bottom number always matches the second one, so that should be a 3. And then these two powers here should add up to be 8. So in this, or whatever this top number is. So in this case, 3 plus 5 would be 8. So my p is 3, n is 5. Same thing here. Now this time I don't have the bottom one, but I know the top two should equal 9. That makes n 5, and that makes p 5. So n is 5, and so is p. Over here, right, the bottom was 3 again. So that matches this guy. That's 3. And then these two have to add it to be 10, so this makes this 7. N is 7, p is 3. Okay, now we're going to actually expand these binomials. Now remember, one way to do this is go x plus 3 times x plus 3 times x plus 3 times x plus 3. That's the long way. We're going to do the binomial expansion formula, which says we start here with power. So 4 over 0, first term, second term, plus, keep going, 4 over 1, first term, second term, plus 4 over 2, first term, second term. We're going to do this until we get until they match. 4 over 3, let's go do this one more time after this, plus 4 over 4, first term, second term. Okay, so we have all that written out. Now, if someone done with this, I still got to write the powers. Now, the way the powers works is the we just talked about. The bottom number matches the power of the second. And there's a reason. Whoops. There's a reason I do it this way. Some teachers say count up, count down. I don't like that. I prefer this much more. Okay, so we have those. And then I'm going to add these to that power. So that makes this So that's 0, this is 4. That's 1 must be 3. 2 and 2 equal 4. 3 and 1. And 4 is 0. Right, so remember, these two powers have to, the power of these two terms have to add up to be the top power right there. The bottom one matches the second one. That's most of this. Now you just got to simplify it. Like I talked about before, anytime you see anything over 0, it's automatically 1. X to the 4th is just x to the 4th. Anything to the 0 power is 1. Anytime the number is over 1, it's just the top number, so this is 4. X to the 3rd is x to the 3rd. And then 3 to the 1st is just 3. Now, forward 2, there's no shortcuts for forward 2. You either got to know how to do it or just memorize it at a certain point. Remember, we could also do Pascal's triangle for that if we wanted to. I'll do that on the side so you can see it. We haven't done it that way. So 1, 1, 1, add these two, 2, 1, 1, 3, 3, 1. Right, remember, all I'm doing is going 1 and then add a 1. So now you add these so you get 2. On the ones on the side, you bring the ones on the side again, add these so you get 3, add these so you get 3. So 1, 3, 3, 1. I'm going to have 1, and I'm going to add these 2. 1 and 3, so I already get 4. Add these 2, I get 6. Add these 2, I get 4, and then put a 1. So 1, 4, 6, 4, 1. So how's that help me here? So this is 4, 2. So what we do is go to row 4, which is the first number has the first non-1 number. Tells you what row it is. This is row 4, row 3, row 2, row 1, row 0. So this is like, this 1 right here is like, it's the same thing as 4, 0. So you get 1 just like we got here. 4, 1, we the same thing as saying 4, 1. We start at 0 when we start doing these. So 4, 0, 4, 1. This will be 4, 2, which is what we're looking for. This will be 4, 3. And this will be 4, 4. So right here for 4, 2, it should be 6. So that's how you do. That's how you use Pascal's triangle. You always start at 0. So the row number is the first number that's non-1, and then you always start counting at 0. So this will be 3, 0, 3, 1, 3, 2, 3, 3, 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. So I get 6. Then x squared, 3 squared is 9. Plus 4, 3. Remember what I said earlier? Anytime the difference is 1, it's the top number, so it should just be 4. And it also matches with our Pascal's triangle. That is 4. Then x, and then watch out, 3 cubed is 27. Remember, these are all being multiplied. And then the last row, 4, 4, anytime they're the same, it's automatically 1. It also matches over here. Ending to the 0 power is 1. And 3 to the 4th is 81. So, okay, next we just simplify all this. So I think my final answer is going to be x to the 4th, 1 times all that. Over here I get 4 times 3 is 12, so 12x cubed. 6 times 9 is 54, 54x squared. 4 times 27, that's 4 times 20, which is 80, plus 4 times 7, which is 28, so 108. And then 81 times 1 is 81. And that is x plus 3 to the 4th expanded. This is the next one. Same idea, but only to the 3rd power this time. So again, we're going to do the exact same thing. We're going to set it up. We always take the top number, so 3 over 0, then first term, and then second term. Plus the next term, 3, 1, first term, second term. Plus, keep on going, 3, 2, first term, second term. Plus 3, 3, first term, second term. Okay, now we do all the powers. So remember, the bottom powers matches the second one, the power of the second guy, so 0, 1, 2, and 3. These two powers are added to be the top number, so in this case that would be 3, 2, 1, and 0, right? Because 2 plus 1 equals 3, 1 plus 2 equals 3, and so on. And once we do all that, all we have to do is simplify it. So remember, anything to the 0 power is 1. Now here's where a lot of people make a mistake. So 2x cubed, it's not 2x cubed. That sounded funny. This 3 goes to both of them. So it's going to be 2 cubed and x cubed. So it's going to be 8x cubed. Anything to the 0 power is 1. Plus, when we move on, 3 to the 1, remember, anytime the bottom one's 1, it's automatically top number. So it's 3. Over here, same idea. Goes to both of them. 2 squared and x squared is 4x squared. 2 squared is 4. And then negative y to the first is just negative y. We'll talk about that in a bit. A lot of people mess that up too. Next one, 3, 2. Remember the difference is 1. It's automatically a top number also, so 3. Or if we want, we can look at Pascal's triangle. It should be 1, 3, 3, 1. So this should be 1, 3, 3, 1. Remember, you can also use your calculator if you wanted to. I'm mostly try to do it by hand, but just to show you, remind you guys how to do it in your calculator. If you want to do your calculator, what you do is, this is going to be math, probability, and CR. You just got to put the numbers in. So you want to put the number in first. So I actually messed that up. I would have put 3, then math, then probability, and then NCR, and then 2. So then I'll find it for this. So 3, like we have. So again, I'm also going to do it either by hand or with the Pascal's triangle. If we get big numbers, which we'll do later, then we'll do it with the calculator. So this would be 2x, and then negative y squared. Remember, anytime you square a negative, it becomes positive. So anytime the power is up, and you have a negative number, and you have an even power, it's always positive. So this would be just y squared. The last one, anytime they're the same, it's automatically 1. And these are 0 power is automatically 1. And the last one, anytime you have a negative to an odd power, it stays negative. So this would be a negative y cubed. Then all we do now is simplify it. This would just be 8x cubed. That's just simplified by 1. Here's important. A lot of people give me this all the time. I always see this. And that is disgusting. That's wrong. You're multiplying these, not adding them. So, yuck. And actually, it's a negative. So negative 12x squared y. Over here, nice and easy. Just 6xy squared. And the final one, all I have is negative y cubed. And there's my answer. Let's do one more where we expand the whole way. And then we'll do the single term ones after this. So let's expand this one the whole way again. So very simple. We just start at the highest power. So 4 over 0. First term. Second term. That's a negative. So I have to keep the negative there. Plus 4. We just come on counting up. 4, 1 until they match. Until we get 4, 4. 4, 2. 4, 3. Plus 4, 4. Okay, then we do the powers. Alright, so we'll go a little faster here. It says 0, 1, 2, 3, and 4. Right? They always match the bottom term of this, always matches the second one. Then these two have to add up to be 1. So this would be 3. This would be 4. Going in a lot of order here. 2, 1, and 0. All we do now is simplify. Luckily we did 4, 0, 4, 1, 4, 2 before. I know it's 1, 4, 6, 4, 1. And we did earlier. It's from Pascal's triangle. Or you can do each one separately. Now let's do the numbers next, or the rest of it. So this one, remember, power to a power you multiply. So it should be x to the 8th. So over here I should get x to the 8th. 1 times x to the 8th technically. And 10 to the 0 power is 1. Next one, that is a 4 already. Again, power to power you multiply. So x6. And remember, anytime it's an odd power, you keep the same. It keeps the negative. Next one, we know it's a 6. Power to power you multiply. So x to the 4. I guess in that case, it doesn't really matter. This is an even power you're taking it. So it's becomes a positive y to the 6. And same rule, power to power you multiply. Next one, 4 x squared. Power to power you multiply, but it's an odd, so it stays negative. And the final one, 1. 18 to the 0 power is 1. So I get negative y cubed to the 4. So it's become positive because it's an even power, and then you multiply them, y12. If you want to simplify a little bit, x8 minus 4x6y cubed plus 6x to the 4 y to the 6 minus again 4x squared y9 and then plus y12. That's final expansion. It's one of my favorite things to do in mathematics. So next, that's actually a lie because it's a little long. This is one of my favorite things to do. Find an indicated term. I love doing this thing. So I want me to find the third term of this expansion. So we don't have to find the whole thing. Just got to find the third term of it. So here's the key to that. Like everything with binomial expansion or Pascal's triangle, it's all about starting at 0. Remember when we did Pascal's triangle? The first term is a 0 term. Move this a little bit. It's bugging me. So same idea here. If I did the first term of this, I would expand the 7. It would be 7, 0 would be the first term. The second term would be 7, 1. And the third term would be 7, 2. So that's what I want. I want to expand the 7, 2 term. like over here, right? This was the first term, this was the second term, this was the third term, right? It was 4, 2. So anytime it's a term number, it actually starts at 1 below because you have to start at 0. So it starts actually 1 less. So all we gotta do is expand that guy. So we're gonna go 7, 2. First term is x from here. And the second term is 2z. And all we do next is fill it out. So, right, the bottom number matches the second one. And the power of these two has to add up to be that number. So this has to be a 5. That's it. Now we just gotta simplify it. 7, 2. Don't have that off the top of my head. So we're gonna use a calculator for that. I'm gonna go 7, math, NPR, NCR, sorry, and then 2. And I get 21. X to the 5th is just x to the 5th. 2z squared, remember that 2 goes with both of them. So it becomes 4z squared. Z squared both of them. Then just multiply. 21 times 4 is 84. So 84 x to the 5th z squared. Done. Next one, they want the fourth term of this. Again, I'll write this out so it's easier to see. 6 0 will be the first term. 6 1, 6 2, 6 3. It always starts at 1 lower when you want a certain term. So we're just going to expand 6 3. First term. Second term, don't forget the negative. Right, the power of the bottom one matches the power of the second one. And then these two have to add up to be that number. So the power of this guy and the power of this guy have to be the top number, which would be 3. Now we just expand it. 6c3. I feel like I should know that for my calculator. I'm just going to do I'll do the formula this time. Right, so that'll be 6 factorial over 3 factorial. Subtract them. 3 factorial. Expand the top one until you get to the highest one at the bottom. So that's 6 times 5 times 4 times 3 factorial. Now they're both 3, so I'm just keep one and I'll expand the other one. These reduce. 3 times 2 is 6. So I just get 5 times 4, which is 20. Yeah, you can also do it in your calculator if you want. But I'm going to start using the formula a little bit more. So there's 20. Y cubed is just y cubed. And then negative 3x to the third power. Remember that goes to both of them. And it's an odd power, so it stays negative. It's negative 27x cubed. And like I talked about before, this is not my answer. You're multiplying. So whatever 20 times 27 is, it's not too hard. 0. And then 4. And then negative 540. X cubed, y cubed. Remember, we generally like to write our variables for alphabetical order. So it's not wrong the other way, but the more proper way is alphabetical order. And there's the answer. Find the fourth term of the expansion of this one. So I want the fourth term. So same idea. It would be 9, 3. Remember, 9, 0 is the first, 9, 1 is the second, 9, 2 is the third. 9, 3 would be the fourth term. First term, second term. Power of the bottom has to match the second guy. And then these two guys have to add up to be the top number. So 6. So really all you have to do is this guy, 9c3. So I can use the formula, I use the calculator. 9's a little big, so I think I'll just use the calculator. 9 math, probability, NCR, 3. So 84. Then this is just C6, and that is just D3. Done. What was the coefficient of the fifth term? It's kind of beating a dead horse here. Same idea. 6, 4. Right, remember again, 6, 0, 6, 1. It's always one less when you look at fifth term. So I'm going to expand that one. So 6, 4. First term, second term. Bottom one has to match the second guy. So this is 4. And then these two have to add up to be that number. So this would be a 2. Then we just expand it. 6, 4. That one I should know. I'm gonna do the formula real quick. 6 factorial, 4 factorial, 2 factorial. 6 is the same thing as saying 6 times 5 times 4 until you match the bottom one. You expand the smaller one, 2 times 1. 6 and 2 reduce. So I get 15. Then this guy is just m squared. This goes to both of them. So 3 to the 4th, which is 81. N to the 4th. Now I have 15 times 81. Do I know? I don't think I know that. Let's use my calculator real quick. And I meant times, not plus. I could do 15 plus 81. I should be able to do 15 times 81. 1215. That's embarrassing. So 1215 m squared n to the 4th. So there we go. Now we go to the even more fun ones. Is that anything? I like these even more. So this one's a little bit like you have to solve it. You have to think logically more on these. find the coefficient of the x to the fourth in expansion of this. So they don't tell you a term number, they just tell you, hey, this has an x to the fourth in it. What's my answer? So what I do is write what you know. So how would I set this up no matter what? I would write the first number. Let me do some black. I'll write the top power over some number on the bottom, which I don't know. I'll write the first term. I'll write the second term. Right? That's all we know. That's an n. So that's all we know. Right? And then what do I want? I want x to the fourth. Well, how do I get that? Look at my x here. What power must I have? Well, 4 is what I want. Then fill out the rest of it. Well, if that's a 4, I know this has to be a 3 because, right, these two powers have to be 7. If this is a 3, the bottom was a 3. And then all we have to do now is simplify it. 7, 3. I'm going to do this by hand. So 7, 3 factorial, and the subtraction will be 4 factorial. It'll be 7 times 6 times 5 times 4 over 3 times 2 times 1 times 4 factorial. Right, I reduce the bottom one. Sorry, the top one until I got to the highest number on the bottom, which is 4. You always leave the highest number on the bottom because that's going to cancel out, and then you always expand the smaller one. So 3 times 2 times 1. The 4's cancel out. 3 times 2 times 1 is 6. Same thing as cancels out to 6. And I just get 35. So this is 35. X to the fourth. And then this goes to both of them, don't forget. So 8. Y to the third. 35 times 8. So it's like 40 plus, what's that? Is that 240 plus 40, I think? So 280, I'm going to say. I'll double check that in a second. I was doing 80 times 5 plus 80 times 30. Or 8 times 5 times 8 times 30. So what I was trying to do. See if I was right. I got some skills. So you got that. So we're going to do a couple more of these, the same ones. I love these. So with the next one, same idea. So all I'm going to do is write out what we know. We know it has to be a 6. First term has to be an x. Second term has to be a 5. I want x to the third. So that means my x has to have a power of 3 in it. That makes this have a power of 3 in it also, because these have to be up to 6. Bottom has to have a power, that has to be 3 also. This would be x to the third. This would be 125. And then 6, 3. Oh, we just did that. Where do I have it somewhere? There we go. It's 20. I don't want to memorize, but these are what we have. So 20. Multiply all together. This is not too bad. I get 2500 x cubed. Just 2 times that, add a 0 to it. So there's the answer. Next one. A little trickier in this case. They want x to the 10th in this expansion. So again, write what you know. I'll write 10, first term, second term. And I want x to the 10. So here's my x. Now here's the thing a lot of people put. They just put a 10 right there. That would be wrong. If I put a 10 there, you multiply the power, so you actually get 20. All I want is x to the 10 in my answer. So this actually has to be a 5. Right? Because power to power you multiply, you get x to the 10th, which is what I want. And that's the right answer. We simplify the rest. If that's a 5, this has to be a 5 also, because the bottom one, the R, or the bottom number always has to equal to the second one. And then this has to be 5 also, because these two have to be 10. Now, I definitely don't know what 10C5 is off the top of my head. So that one, that's what calculators are made for. So 10, math, NCR, 5. So I get 252. 3 to the 5th is 273. And remember, this is the 5th power. So I get 2 to the 5th, which is 32, and x to the 10th. So 32 times x to the 10th. We'll apply all that together. Now, I wasn't too sure about that. I'm pretty sure it's 273, but just to be safe, I'm going to multiply this by, I'm going to put 3 to the 5th. And I'll put times 2 to the 5th also. Oops, 2 to the 5th, not 5 to the 5th. And I get that number, 1959552 x to the 10. That's the idea, right? So that's how we do it. That's kind of the general idea. If you can do that, you're going to be solid. Now let's go to the even more crazy ones. I had to fill out more of the worksheet, honestly. So this is something you won't see in Honors Aptitude Trig. You will probably see it next year, or depending on what you take next year. So we're going to expand this, but there's 2 x's here. As you guess, that probably makes it more complicated. So why these are like the advanced problems. So how does this work? Well, let's start off writing what we know. So if I was going to expand this, it would be 6 to something, first term, second term, like that. Now, what a lot of people prefer to do is kind of make an equation out of this. We're going to make this A, we'll make this B. What do we know about A and B? If we add them up, it should be 6. A plus B should equal 6. And we'll have to, then how would I expand this? Well, you would multiply A by both of these, and you multiply B by this. So ignore the numbers, I don't care about the numbers. Let's look at the powers. I'm going to get x to the 2A times 1 over x to the B. Kind of like that. Remember, again, ignore the numbers, it doesn't really matter. All we care about is the variables. So if I expand this, I get x to the 2A times 1 over x to the B. This would get me x to the 2A over x to the B, also known as, right, top minus bottom. If you have the same base, you subtract the powers. 2A minus B. Why is this important? Well, what do I want my answer to be? X to the third. I want 2A minus B to equal 3. So that's my second equation. 2A minus B equals 3. Now if you could solve this, we're good. So let's solve this formula real quick. Add down, you get 3A, B's cancel out, equals 9. Divide by 3. So A equals 3. So if A equals 3, how do I find my B? We'll plug it back into here. If A is 3, B also must be 3. So now I know my variables. I can go back here and plug in 3 and 3 for my A. Now I get this. I'll write it down here because I'm running out of space. So it's going to be 6, 2x squared to the third, negative 3 over x to the third. Now remember, if that's a 3, so is this guy a 3. Now all we got to do is expand it. 6, 3, we did that on the y, that's 20. This one, multiply by both. So I get 2 to the third, which is 8, and x to the 6. Over here, that 3 goes to both of them also. Negative 3 to the third is negative 27 over x to the third. Then we multiply it all together. Notice x to the 6 divided by x cubed is this x3, which is what we wanted. And then here we can multiply all that together. I'll use a calculator for that. So 20 times negative 8 times negative 27. And I get 4,320. And that's the idea. Alright, so again, that was a complicated one. You won't see one like that this year, but just so you can see, that's like generally how ugly the ugliest it possibly gets for a binomial expansion. So like this, you go, okay, write an equation. I know it has to be an A and B. Don't know how to do it yet, but I do know A plus B has to equal 6. That's the top number. And then if you expand it out, you go, just care about the variables. What's my A and B equal? I get 2A minus B as the powers, and that has to equal 3. Next one. Expand the binomial 2x minus 1 to the 4th. Oh, these again. So they want us to, when they say that, they want you to do the whole thing. So you got to go 4, 0, first term, second term, plus 4, 1, first term, second term, plus 4, 2, first term, second term, plus 4, 3, first term, second term, plus 4, 4, first term, second term. Then we do all the powers. So that'll be 0, 1, 2, 3, 4. And then remember, these have to add up to be that guy. This is a 3. This will be 1. That was not a 3. That was a 1, so this has to be 3. Sorry, this is a 4. Here's a 2, a 1, and a 0. Remember, the reason I go count up and count down is because when we find a single term, then the count up, count down doesn't help you. So that's always go, okay, the bottom one matches the second one. Anyway, from here we simplify. 4, 0 is 1, 2, that goes to both of them, so I get 16x to the 4th, and 2 to the power is 1. 4, 1 is 4, this goes to both, so I get 8x cubed. That stays negative 1. This is 6. We've done that a lot. This goes above, so 4x squared. Anything to, and when you square it, becomes just a 1. This is a 4. 2x. Anything to the odd power stays odd, or stays negative, sorry. This is automatically a 1. They're the same. Anything to the 0 power is a 1, and anything to the even power is a 1. Even power makes it positive, so 1 to the 4th. Negative 1 to the 4th is just 1. So we get this, and I get 16x to the 4th plus 30 minus 32 x to the 3rd plus 24x squared minus 8x plus 1. So that's the full expansion. Now look at this one. Now it gets complicated. Find the coefficient of x cubed into the expansion of this. So this answer we already have up here. We did all that. So actually, let me rewrite it. So this is like saying x plus 3 times, what do we get? 16x to the 4th minus 32x cubed plus 24x squared minus 8x plus 1. What do they want? They want x cubed. So let's think about this. How do we find x cubed? Well, if we expand 3, it's going to get multiplied by every single one of those. Only one I care about is x cubed, though. That's all I care about. So all I'm going to care about is 3 times this guy, because that's going to give me x cubed. I'm going to get 3 times negative 32 x cubed. How about x, though? Right? If we expand this all the way to be 3 times all these, then we're going to go plus x times all these. Which x do I care about? I want x times 24x squared. Right? X times 24x squared is going to give me x cubed. We'll add it to this answer we already have, the thing we already have. So we'll get x times 24x squared. Simplify it. 3 times negative 32 will be negative 96 x cubed. Plus x times 24x squared would be 24x cubed. Add them together. That's like, what's that? 72? Negative 72 x cubed. Right, so that's a fancy one. We're using an answer from before and then trying to figure out x cubed. That's more kind of an algebra problem. You have this. How do you find x cubed? Well, it'll be 3 times the cubed one, because that doesn't change the power of the x. But x will change the power of the x, so it's x times the one below it. X times x squared will give me x cubed. Add those together, you get your answer. Next one. The figures below show a pattern. This is more of a chapter 10 review in general. The figure below show a pattern of filled squares and white squares. Write an equation representing the nth number in the pattern where the n is the number of white squares. So, again, this is the first. This is like A1. We're counting the number of white squares. So, in this case, A1 equals 4. Here's our A2. Again, we're counting the white squares. So, 4 plus 2 is 6. A3. So again, we're counting the white squares, so it's 6 plus 2 more is 8. So if you look at it, if we're just counting the white squares, it looks like we're just going up by plus 2. So that's all that's going on here. So my equation, they want an equation. This is, since we're going plus 2, that's an arithmetic sequence, which is this formula. AN equals A1 plus N minus 1 times D. So what's my A1? That's 4. And we're going to leave the n's out of it because we want the equation. What's my d? Plus 2. Let's simplify this because they want the actual equation. So it'll be like this. And I get an equals 2n plus 2. So that's the equation, right? You could double check if you want. Plug in 3. Plug in 3. My third term should be 8. 3 times 2 is 6. 6 plus 2 is 8. So it checks out. Is it possible to have exactly 84 white squares in an arrangement? Explain. So they're saying, is 84 possible for this part? I don't know. Let's solve. Let's just do that. Plug that in for an and see what happens. 84 equals 2n plus 2. Subtract 2. I get 82 equals 2n. Divide by 2. N equals 41. So yeah, it's possible. It'll be the 84th. It'll be the 81st term. Now, if I would have got a decimal for that, like if I would have got 84.2, then no, it's not possible. Because the only thing we can plug in is natural numbers. So in this case, it worked out. So we know what term it is. If you do 41 of these, that'll be, in that case, we'll have 84 squares. I don't know what it looks like, but we'll have 84 squares. Find the indicated term of the arithmetic sequence. So again, more review. So remember, it's an arithmetic sequence, so we have this. So you're looking for the indicated term. So we want that. Oh, we want the ninth term. It's been a while. So plug in what you know. I want A9. So it's going to be A1 plus n minus 1 times d. Plug everything in. The first term is 10. N is 9. And the common difference is negative 5. So I get 10 plus 8 times negative 5. So 10 plus negative 40. So negative 30. Finding the term for the geometric sequence. The same question, but now geometric sequence. So remember, that formula is a little different. That is A1 times r to the n minus 1. Plug in what we know. I know A2 is 8. I don't have A1. So remember, if you remember what I said, anytime you're missing something, go back to the original equation, plug in what you do have. So I go back to the original equation and plug in what I do have. I know when I plug in 2, it equals 8. And then I know the r is 2 also. So I have this. 8 equals A1 times 2 to the 2 minus 1. So I have 8 equals, I didn't have to do this. It's too much work. 2, so A1 equals 4. Which is right. I forgot I had A2, right? If I had A2, and I know that's 8, and they tell me the r is 2. So say when you multiply by 2, you get your next term. You can always do it. By the way, this is always a fine method. It's just not the fastest method. Right? If I really want to find A8, I can just multiply by 2 over and over again until I get to the 8th term. But in this case, I was like, I had the second term. I could have gone backwards. I could just divide it by 2 and got 4. Made it a little easier for myself. But whatever. We're here now. So I want the 8th term. So I know the first term is 4. I know r is 2. And I want the 8th term, so you plug in 8. So you get 4 times 2 to the 7th. I don't know what that is. It's like times 120 something. So let's just do it. 4 times 2 to the 7th. I get 512. Last couple review questions. Find the sum of the infinite series if it exists. And remember, infinite series, that has to be geometric. So this is the equation. Sum infinity is A1 over 1 minus r if r is less than 1. Absolute value of r is less than 1. So remember, these are geometric sequences like we just did. This is my A1. This is my r. Sitting here, this is my A1. This is my r. So this first one here, r is 2/3. That is less than 1, so I could use this. So all we're going to do is use the formula. A1 is not 12. Then it's 1 minus r, 2/3. So I'll get 12 over 1/3, right? Common denominator. This is the same thing as saying 12 divided by 1/3. Or 12 times the reciprocal, which is 36. So that's my sum there. This one, my r is bigger than 2, so not possible. It's a divergent series. Not possible. So done there. One last question. Find Sn for the arithmetic sequence. So they want me to find the sum of this guy. Now it's an arithmetic sequence. Remember, the sum is, there's two formulas. There is this one. And then there is also this one. Now we have a problem in either case. I know my A1. I have my AN. I have my common difference, which is 5. But I don't have N. And N's kind of important to the formula. Look at both formulas. They have AN. That means they have N in both of them. So it doesn't matter. In this case, I'll probably just use the top one because I just got to find N and then plug into the easier formula. How do we find N? Same thing as always. If you're missing something, go back to the original formula. So anytime you're missing something, go back to the original formula and plug in what you know. So my first term is 9. Common difference is 5. I don't know N, but I do know AN is 74. And I need to simplify. Subtract 9, subtract 9. I get 65 equals n minus 1 times 5 divided by 5. 13 equals n minus 1. Add 1, n equals 14. So now I know n equals 14. I go back into this equation right here. Plug in 14 for n. A1 is 9. And then remember, AN is not 14, that's N. AN is 74. If I do that, my sum of the first 14 sequence terms is 7, 14 divided by 2, times 9 times 83. 7 times 8, it's like that. 9 plus 74, which is 83. Multiply those together. So 21, 56, so 581. And that's this worksheet.